Welcome back to STS. In today's video, we're going to find the area bounded by the curves f and g and the line x equals 2. Here, as we look at function f, we see that there is a reciprocal function, 1 over x. We see that function g is just a line that goes through the origin, and we see that x equals 2 is a vertical line going through the x-axis at position 2. Let's go ahead and create a quick little drawing of what we have here. We know that when the x value is 1, we know that the y value is also 1 for the reciprocal function f. We know that for function g, that the x and y values are going to be the same. So we have an intersection here at 0, 0, and we also have a point here at 1, 1. And lastly, we know that when x equals 2, we have a vertical line that goes through the x-axis at position 2. So the area in question is here. What we want to do now is to verify our boundaries. So we do that by setting function f and function g equal to each other. So I'm going to start here by saying 1 over x, which is function f, is equal to function g, which is just x. But x is understood to be over 1. Let's cross multiply to simplify. So I have x squared is equal to 1, but I want to figure out the value of just x. So I take the square root of both sides. So here I have x is equal to plus or minus 1. But based on our picture, we see we only care about the positive value 1. So we see that our boundaries or our limits are at 1, and it was given that our other limit is at 2. Graphically, we can see that function g is above function f over the interval 1 to 2, but let's verify that. And that's done by picking a point in between the interval. Let's pick the point 3 halves. 3 halves is also 1 and a half. And we're going to substitute 3 halves into both the f function and the g function. And we're expecting the g function to give us the larger value because it is at the top. So for the reciprocal function, when I put in a 3 halves, it actually flips it to the reciprocal, which is 2/3. And for g of x, when I put in 3 halves, I see the answer is still going to be just 3 halves. Well, 3 halves I know is the same thing as 1 and a half, and 2/3 is decimal point 6 repeating. So here we see that function g is the greater function, which means that function has to be listed first when we create our integral. So with the integral, we know the boundaries or the limits are from 1 to 2. We know that the g function has to be listed first, which is just x, and we're going to subtract off the lower function, which is f, which is just 1 over x. And we put in the dx for proper notation, and now we need to integrate both of these terms. So x becomes x squared over 2 minus, and 1 over x is the natural log of x once that's integrated. Now we put in our limits, again from 1 to 2, and we do a basic substitution. So for the first one, for the upper limit, 2 squared is 4, and 4 divided by 2 leaves me with 2, minus the natural log of 2, minus the lower limit. I input a 1 for the x values, so 1 squared is 1, divided by 2 leaves me with just 1 half, minus the natural log of 1. Alright, at this point I need to again simplify, so I'm going to distribute this negative to both of these terms. So I have 2 minus the natural log of 2 minus 1 half plus the natural log of 1. At this point I have 2 minus 1 half, well, minus a half, that becomes 1 and a half. And then I have plus the natural log of 1 minus the natural log of 2. Using the properties of the logarithms, I can simplify this to plus the natural log of 1 half. So this here is going to be in square units. So this here represents the area that you see shaded here. So let's go and call up the calculator and just verify that result, or show the decimal approximation of that result. So here it was 1.5 minus the natural log of 0.5. And we press enter here. Whoops, I'm sorry, it wasn't minus, it was plus. So let me go back up and let's grab this here. Let's go back. It was actually plus, so let's go over again, change that to plus. And we see that we have the approximation. I'm going to put the decimal point 8069. So here we're saying 8069 square units. Now let's go ahead and take a look at this graphically. So let's call up y equals. Here I have function f and function g already in place. Let's go ahead and graph. We see that all the information we are interested in happens in quadrant 1. So zoom. Let's do alpha and then A. And we see the x value, its maximum. Let's give it a maximum of 3 for x and y. So let's go to window. Let's give the x max a 3. And let's go down and give the y max also a 3. And then let's graph again. We see that everything is taking place in this region here. What we need to do now is take function g and subtract it from function f. So let's go back to y equals. Let's go down to the third location. Function g is x. So we're going to do x minus x raised to the -1 power. And we're going to graph that. And what we want to do now is integrate from position 1 to position 2. So let's click on second and then trace. Go down to option 7. And the lower limit, first let's make sure we're in the right graph. We're on graph 1 right, or function 1 right now. We need to be on function 3 because function 3 is the g minus f. So we're on the right function. We see the color change to black, so we know we're in the right place. The lower limit was 1, so 1 and then enter. The upper limit was 2 and then enter, and we see it shade in, and we see the result does come out to be approximately what we found by hand with the decimal point 80 and 69. Alright, that sums up this video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to that YouTube channel. And as always, thank you for watching.